Today we are going to solve the Gaussian integral and we are going to discuss about their application. This problem is not related to Griffith, it's a general problem. You might have noticed in a few of my lecture I have discussed about the Gaussian integral. Frequently we are using in quantum mechanics. So I want to give separate lecture on Gaussian integral, which will be very much useful for our problem solving technique. Now our aim is to solve the Gaussian integral. Let I equal to integral over minus infinite to plus infinite e power minus x squared dx. This is a Gaussian function. You know the Gaussian distribution is it is like this. If you find area, after all, the integral is area under the curve. You have equal area in the positive x-axis and equal area in the negative x-axis. If you add this, you will get 0. Gaussian function is a even function. The integral of even function between the symmetrical limit is 0. That you know. To solve this, we are going to do a small trick. You square the integral, that is the whole thing squared, which is equal to multiplication of I into I. This is equal to I multiplied by I. So now what we are going to do is in the second integral, you change the variable, replace the variable by y. Just because replacing the variable, the integral value will not change. We know it. So this will become, first integral is with respect to x, second one is with respect to y. So we can combine both. You can bring it here. So it will be a double integral e power minus x squared plus y squared dx dy. So, you know, this x square plus y square is equal to r square in spherical polar coordinate. And dx dy is the small area in Cartesian coordinate. When you replace into spherical coordinate, this is equal to r times dr into dt. So now you replace this x plus y squared as r squared, and this one is r dr d theta. Now theta part I have separated out. Theta part, the value limit should be 0 to 2 pi. So it will have rotation 0 to 2 pi. That you know. Then this r, I am keeping r term as a one integral. So theta is one integral and r is one integral because I have changed in terms of r and theta. Uh, However, the limit for r is not to 0, is not to minus infinite to plus infinite. You know very well. Due to spherical symmetry, r, whichever direction you take, that will be symmetrical one. So the limit is changed from minus infinite to plus infinite, 0 to infinite. So, you know, this integral, first integral value is 2 pi. So naturally, we will have 2 pi times integral over 0 to infinite e power minus r squared r dr. So we will see what will happen to this. Now we got that square of the integral I squared is equal to 2 pi times integral between 0 to infinite e power minus r squared r dr. Now I am going to keep this minus r squared as u. Then du is equal to minus 2r dr. That is, if you bring this minus to the left hand side, you will get minus of du is equal to r dr. So now you replace r squared as u. Here you come minus r squared as u. Then r dr is equal to minus of du. So minus of du. Now this 2 will get cancelled. You will get minus 5 outside, and if you integrate it, you will get EU. Uh, and here I like to highlight one important point. When in the original coordinator, when r equal to 0, u is equal to 0. Uh, when r is equal to infinite, r is equal to infinite, then u is equal to minus infinite. I have changed the limit also. That also you got to take care. Here, as I said, 2 will cancel out and minus pi. You will get minus pi. If you integrate this EU, you will get EU by applying upper and lower limit. If you apply the upper limit, it is 0. E power minus infinite is 0. E power 0 is 1. So upper limit minus lower limit. So which is equal to minus 1 into minus pi, which is equal to plus pi. So now we got I squared is equal to pi. Then what is I? I is equal to square root of pi. So naturally we have taken this as our original integral. So that means our integral is between integral between the limit minus infinite to plus infinite e power minus x squared dx is equal to square root of pi, because I squared is pi. Naturally I is a square root of pi. So this is the value of Gaussian integral. You have to remember it. We are going to use this frequently in quantum mechanics. Now we will see the integral. This is also Gaussian. It's a general form of Gaussian integral which we are frequently using in quantum mechanics. That is, I is equal to integral over minus infinite to plus infinite e minus alpha x squared. Alpha is some constant integrated over dx. Uh, Now, as usual, you replace this x squared plus y squared as r squared, and similarly the dx dy as r dr d theta. Then you separate the variable. So I have separated and changed the limit. Just now I explained, so I don't want to explain it again. So this d theta integral limit will become 0 to 2 pi. This r, for r it will become 0 to infinite. So e power minus alpha r t r. Now what I am going to do is I am going to take minus alpha r squared as u. Then du will be minus alpha it's 2r dr. Then what is this RTR that we have to replace? RTR is equal to uh, du divided by minus 2 alpha, because I am bringing this minus 2 alpha this side. So this will become uh, minus 2 pi is the result of this first integration. So 2 pi divided by minus 1 by 2 alpha, this 2 alpha EU du. Just now we have seen this integral, and the reason I for changing minus infinite also just now I explained. So this integral value is minus 1. So naturally minus of minus will become plus. So this will be I squared integral is equal to pi pi alpha. Then I is equal to this integral. I is equal to square root of this one naturally. So square root of pi by alpha. This result we are actually using more most frequently in quantum mechanical problem. Now we want to find the integral, the solution for the integral minus infinite to plus infinite x squared e power minus alpha x squared dx. Remember that in order to find the expectation value in quantum mechanics, if wave function is like this, then x squared psi star psi. So naturally this integral is very, very important to solve most of the quantum mechanical problem. Now I'm going to apply a small trick. Just remove the x squared from this integral. Later on, we are going to add it. Right now, you just remove this x squared. So naturally, this will be the usual Gaussian integral. Then, what is the result of this integral? E power minus alpha x squared dx integrated over minus infinite to plus infinite. Just now we have seen this is equal to square root of pi by alpha, which is equal to square root of pi. This alpha I am writing as alpha power minus half. So now I am going to apply a small trick as I said. You differentiate this exponential term with respect to alpha. Remember that this is with respect to alpha, not with respect to x. uh, this is equivalent to, you see the right hand side, square root of pi, and you here only alpha term contain. You are taking the derivative of alpha power minus half with respect to alpha. So both are equivalent. See here, I am introducing the differentiation t alpha by t by t alpha. Here I am introducing t by t alpha. Now, what will happen if you differentiate this with respect to alpha? You will get minus x squared, e power minus alpha x squared dx. So we removed it, we got it in the other form. Then now you differentiate this, you will get minus of alpha minus 3 by 2. So here minus, both will get cancelled. So you will get the result for x squared integral x squared e power minus alpha x squared dx is equal to 1 by 2 square root of pi alpha power minus 3 by 2. So in a very easy manner we got the result of this integral. So this integral value is 1 by 2 square root of pi alpha minus 3 by 2. So we got this integral value. You may ask what will happen if instead of x we have x squared instead of x squared, if we have x. Naturally that integral will vanish because it's a add integral. Similarly x cube x 5. So this integral exists only for even square of the even number of x. So now you differentiate this again with respect to alpha. Here, introduce differentiation. Here, equivalently, you introduce differentiation in the alpha left hand side. So, if you differentiate this with respect to alpha, you will get minus x squared. Already there is x squared here. This will become x power 4. And then if you differentiate this, you will get minus again. Minus already half is there. Minus 3 by 2 square root of pi alpha power minus pi by 2. So this is, I can write this as minus 3 by 4 square root of pi alpha minus pi by 2. Uh, but instead of writing this, I am writing like this. Uh, 1 dot 3 divided by 2 square. There is a meaning for the same. Both are same, but I am writing this. Later you understand the reason. So square root of pi alpha power minus pi by 2. Then we will see the next case. Now we got this x power 4 integral x power 4 e power minus alpha x square tx is equal to 1 dot 3 divided by 2 square root of pi alpha pi by 3 alpha power minus pi by 3. So now you differentiate again with respect to alpha, both left hand side as well as right hand side. So if you differentiate here, you will get minus x square. Already x power 4 is there, so this will become x. And every time there will be a minus. If you differentiate this, you will get to minus uh, minus pi by 2. So this minus always cancel out each other. So you need not to worry about the negative sign. So here already 1 dot 3 and now again dot 5 divided by this. See, 3 here we have 1 dot 3 dot 1 dot 3 dot 2 square. If you bring this here again, then pi by 2. So pi by 2 already 2 square is there, this will become 2 cube, and you are multiplying this by 5. So 1 dot 3 dot 5 divided by 2 cube, then square root of pi as usual, and alpha, my alpha power minus 7 by 2. So similarly you take another derivative. If you take another derivative, here one minus will come, here one minus will come, you can ignore the minus. So if you differentiate this, you will get x squared. So already x power 6 is there, so this will become x power 8 e power minus alpha x squared. Then already this term is there. Again, if you differentiate, you will get 7 by 2. Of course, I have ignored the negative sign because both side you will always have negative sign. So this will be 7 by 2. So I have multiplied by 7 and 2. Already 2 cube is there. I am writing 2 power 4 square root of pi alpha minus 9 by 2. So you can keep on differentiating with respect to alpha. Here you will get always the even power of x. So we will see the common result now. Now we will consolidate our result and we will make it as a generalized form. So this x squared, this exponential term, if you integrate, you got 1 over 2 square root of pi alpha power minus 3 by 2, and for x power 4 you got 1 dot 3 divided by 2 square root of pi alpha power minus pi by 2. And similarly for x power 6 you got 1 dot 3 dot 5 uh, divided by 2 cube square root of 5 alpha power minus 7 by 2. Similarly for x power 8 you got 1 dot 3 dot 5 dot 7 dot divided by 2 power 4 square root of 5 alpha minus 9 by 2. So in generalized form, see, x is always even. So x power 2n, if you integrate between the limit minus infinite to plus infinite, x power 2n e power minus alpha x squared dx is equal to, you see the numerator here. It is 2n minus 1 double factorial. Double factorial means factorial of odd numbers. So you can see here the power is 2, the factorial is 1, here 4, 3, here 6, only 5, here 8 up to 7. So this is 2n minus 1. This is 2n minus 1 double factorial. Say if you apply this for 1, then this is 1 factorial, and numerator is 1 factorial, denominator is 2 power 1. Because 2n means n is 1, so this will become 2. You check for x power 4. Here 2n, n is equal to 2, so naturally 2 power n, yeah, 2 square, and 3 double factorial. So 1 is to 1 dot 3. Here, 2n minus 1 double factorial is that is 5 double factorial. So 1 into 5 into 3 into 5. And here n, 2n, n is 3, 2 power 3. Like that it will go. You remember this final result. This is very, very important result. Frequently you are going to use in quantum mechanics.